Okay, so same here. Log 36 of 6. So my base is 36. The log is equal to x, so that's my power. And then we have 6. So here we can do the same thing, is try to write it so the bases are the same. So 36 is the same as 6 squared. So this would be 6 2x is equal to 6. Set the exponents equal to each other. 2x is equal to 1. Solve for x. So x is a half. Divide by 2 on both sides. And the next one we have 3 to the x is equal to the 7th root of 3. Since we have a root here, the 7th root, we can rewrite it as 3 to the 1/7. Remember the roots, we can write it as exponents, as fractions, with the index here being your denominator in the fraction. So now we can see that x is going to be 1/7. Letter E, we have log 5 of 1 divided by 125, set it equal to x. So this would be 5 to the x is equal to 1 over 125. So I can try to make them to have the same base. 125 is the same as 5 cubed. But notice that we have 1 divided by 5 cubed. So we can use the exponent rules, and if we divide this, this would be 5 raised to the -3. And so we get x equals -3. Okay, let's try letter F. F through I are special cases, and you'll see why here in a second. So we have log 9 is equal to x. So here x is going to be equal to 1. So 9 to the first power is 1. So if I give you another example that's similar to this one, let's say we have log of 50 of 50. Okay, so it looks very similar to this one, except instead of 9 we have 50. Notice what happens. 50 to the x power is equal to 50. So x is still going to be 1. Well, what if we had log of 1000 of 1000 is equal to x? So we would have 1000 is equal to 1000 is equal to x. So if you notice, as long as these two numbers are the same, our answer is always equal to 1. Okay, so that's actually a property on the next page. That's going to be property number 2. If the base and the number are exactly the same, then your log is always going to be equal to 1. Let's look at letter H or letter G. So we have log 8 of 1 is equal to some number. I have 8x is equal to 1. So any power, if x is 1, that would be too big because that would give us 8. So it has to be less than 1. But what number will always give us a 1 if it's an exponent. And so this is actually a rule. So in this case, x has to be 0. 8 to the 0 power is equal to 1. And so if I give you some more examples, log 10 of 1, then x has to be 0. Okay, or I can say log of 100,000 so it doesn't matter, this is going to be 0. So if you have a 1 here, then your answer will always be x equals 0. So that leads us to the first property on the next page. Log base a of 1 is always going to be equal to 0. And then on the next one we have log 778 is equal to some number, x. So if I change this to exponential, my base is 7. So here you can see the bases are the same. So x is going to be equal to 8. Okay. So notice that the base and this number, which is then raised to another number, are the same, 7, 7. So if we had something like log 50 of 50, 15, then this is just going to be 15. Okay. So notice that 50s are the same, so your answer is just going to be that exponent. So you can see here your answer is an exponent. So that's part of this row here, number 3. If you have the same base, and this is the base of an exponential expression, then your answer is just going to be that exponent x. And then the last one here, this is actually written as an exponent, because notice we start with the 3 instead of log. So I'm going to change this to a log. My base is 3. The log is always equal to the exponent. In this case, my exponent is log 3 of 17. So in order for these to be equivalent or equal to each other, then x has to be 17. So in this case, if we have base 3 raised to a log with the same base, then your answer is going to be this number here, 17.